Hi there, I am El Ghazi Sufyan, Microsoft Certified Data Engineer and Power BI Specialist. In this video, we are going to talk about Vertipaq engine and Formula engine in Power BI. Whether you are just starting out or looking to sharpen your skills, this will help you get one step closer to mastering Power BI. Let's get started. First of all, let's see the architecture. When we have a DAX query generated by the report, by the visual in your report, the query is received by the formula engine, and the formula engine is the first stage of the execution, so which generates the query plan, how it organizes how to execute the query and retrieve the data from the storage where the data is stored. The data can be stored in memory in the Vertipaq engine or in a direct query, for example, in SQL Server. The storage engine is a separate engine that provides the information to the storage engine to execute the query, and during the remaining part of the video we will understand this better. So by going to Power BI, I have here two pages. This first page includes the visual in the import mode, and the second in a direct mode query. So the table that is used in this case is in direct query mode, while the other is in the import. So let's start with the direct mode query. Let's go to the performance analyzer and let's start recording. And we will refresh the visuals, and let's copy the query generated by Power BI and go to the Tax Studio and let's paste it there and see the results of it. So here is the query here. So we will run it. So the result given by Power BI is this table. Now we'll be enabling the query plan and the server timing to see how the query plan of the execution. So here is the query plan. As you see, it breaks it down into many steps. And for the server timing, as you see, the storage engine takes most of the time in this mode, while the formula engine takes only, in this case, 26 milliseconds. So that means that the storage engine is taking most of the time in this case of the direct mode, because it has to retrieve the data simultaneously from the database. So now we'll be doing the same, but for the import mode. So here the table that is used in here is in the import mode. So we'll be doing the same, copying the query generated by Power BI, and we'll be pasting it in DAX Studio to see the query plan and the server timing. So here is the generated DAX query. So now we'll be running it. Now, as you see in here, there is the result. It's the same, and the query plan is also breaks down into many steps. By in the server timing, we have that the storage engine has a 0 millisecond, so it's too fast than the direct query because the data here is stored locally. So we'll be starting with the storage engine. So in this case, we'll be using a simple DAX measure for sales amount, which is calculated using the SumX function. Let's see how Power BI processes this measure, starting with the storage engine. So the step one, the storage engine here is responsible for retrieving and compressing data from the data source. It runs highly optimized queries and works in a columnar format to provide fast performance, and it's using Vertipaq. It's a columnar database for the import mode, and for direct query, it uses SQL directly and runs in the source database. So how does this storage engine work? So when Power BI encounters a measure like this one, so here the formula engine first analyzes the query, and then it asks the storage engine to receive data from the sales table in here. So the storage engine processes the request using Vertipaq, as we said, for imported mode, and for direct query, it's directly using SQL, or the depends on the database, or the mix of both depending on the model. So let's break down the measure in here. So here the sumX is iterating function, meaning it processes row by row, and the storage engine cannot perform a row by row calculation. Instead, it will try to return a pre-aggregated columnar data. So here, what does this storage engine return in this case? So it will give us the sales quantity as a compressed column. It will give us the sales net price as another compressed column. However, since sumX performs multiplication row by row, the storage engine alone cannot complete this task. It passes back the row columnar data to the formula engine, which then completes the multiplication in the summation. So why this is important? Because the storage engine is optimized for fast data retrieval and fast queries. So if we can rewrite our DAX in a way that lets the storage engine handle most of the calculations, our reports will run significantly faster. So it's a good for the storage engine to use pre-aggregated queries like sum cell quantity, for example, and it's bad for the storage engine to run row by row operations like the sumX calculations. So to make our Power BI models perform better, we should always aim to use aggregations that allow the storage engine to do most of the work. So as we specified, the storage engine retrieves columnar data, but it has limitations, so it can't handle row by row operations. That's where the formula engine comes into the picture. So the formula engine here is the brain of Power BI's calculations process. It makes the raw data returned by the storage engine and executes complex operations on it. Unlike the storage engine, which works on columnar formats, the formula engine operates on a row-by-row calculations. So it does not use compression or indexing, meaning it can be slower than the storage engine for large datasets. So how the formula engine will be proceeding with this DAX measure? So the step one, the formula engine will parse the query when this measure is used in a visual. So the formula engine creates a query plan. It looks at which tables and columns are needed, and it requests those from the storage engine. So here the query comes to the storage engine to request the used tables that it receives the data in a columnar base. Then the storage engine receives the sales quantity and the sales net price, and give them in a column compressed format. Then the multiplication is a row by row, meaning that the storage engine can't do it and handle it. Here the formula engine does the heavy lifting, and it takes a row columnar data from the storage engine and performs the multiplication row by row. So it takes each row and multiplies the quantity by the net price, then sums this to the next value of quantity multiplied by the net price, etc., until it sums the results to return the final value to the user. Because the formula engine doesn't use compression and must process data row by row, it can slow down performance, especially for large datasets. So how to optimize the performance? So what makes the formula engine slow is a row by row operations like sumX. So it's slow because it iterates per row, and complex calculations inside iterators like, for example, sumX, and make complicated calculations inside the iterator, and too many functions calls and context switches using if, lookup value, or filter in iterators. So in order to improve the performance, it's better to push calculations to the storage engine if possible, using the pre-aggregated values so that the storage engine can process them, and rewrite DAX to use aggregations instead of iterators. For example, store sales amount in a new column and use the sum of sales amount, this new calculated column, and try to avoid row by row operations unless it's necessary, so using sum instead of summix where it's possible. So to visualize the difference, think of the storage engine like a warehouse worker retrieving pre-boxed items quickly, while the formula engine is like someone manually assembling each order from scratch, so it's slower. So the key takeaway is that the storage engine is fast but limited. It prefers columnar operations, while the formula engine is flexible but slower because it processes row by row data. To build efficient Power BI reports, always aim to let the storage engine do the most of the work. So use DAX Studio to check if your query is using the storage engine or the formula engine. Rewrite inefficient DAX to optimize performance, and try to experiment with performance tuning techniques in Power BI. If you found this video helpful, feel free to subscribe, like, and share it with others. And if you are looking for a complete structured course on Power BI from beginner to advanced, I have got a full course available on Udemy. Feel free to join me there and take your Power BI skills to the next level.